All right, so let's open up that worksheet we had open yesterday, which was 14.1. You guys have kind of seen this, but let's work through. Well, we'll go through. We'll do everything really quick because hopefully this is going to be super easy answers now. So we'll start this again. So David, how do you do a scatter plot? Highlight the data. Insert. I clicked on insert. There we go. Scatter plot. This computer's just waking up, it feels like. Okay, and then how do you put in the titles? Plus sign. Axis titles. What's this down here? Page. The other one's cholesterol. Now we'll pick on Victor. How do I find the correlation coefficient really easily?
O equal Corel.
Corel.
And then there's one, the first line, and then the
First column, comma, second column. And so that is what kind of correlation? It's linear. It looks roughly linear. And is it strong, weak, moderate, or none? Strong. Greater than 0.7. How do I find the OLS equation, Samantha?
You click the plus sign.
You don't click that plus sign. That'll work. But click a point, right-click it, and then go to add trend line. That's a faster way than clicking on that dumb plus sign. Okay? But I know you guys like to take a long time in a test, so. And then what?
Then you can click on the little bar on the side.
Click on the bar on the side?
Like on the right-hand side, there's like the little graph thing.
You already got it pulled up.
Oh yeah, it's already on the bar.
Oh, it's already in the, okay, sorry, I can't see.
Oh. Well, that's why you sit in the back, because you can't see.
No.
And then
Then you can click the bottom two options.
the bottom two options gives you your R squared and your thing, and you probably move that so you can actually read it. Okay? All right, so now the next question is, so that was the quick review. You guys did much better today than you did yesterday, so that's good. So now I want to do a hypothesis test of slope. Okay? So, Tanner, is this quantitative, categorical, or regression? It's regression. Okay? And since that question was so easy, what's the null and the alternative hypothesis? And actually, technically, it should be capital M equals 0. Yes? How do you know? How do you know that's regression? Because you're testing the slope. Testing the slope will be regression. Yep. Okay. And the alternative hypothesis is, Tanner? M does not equal 0. Okay. And now, oh, I forgot to bring my doggone formula sheet. Maybe I have one. Hopefully I have one. Oh, I have one. How about that? I didn't bring them because I didn't have a quiz today. All right, so what's the equation that I do next? We need to find our test statistic, right? And it is a what, Jonathan? It's a t-test because we don't know the standard deviation, and we'll never know the standard deviation on a slope, ever, okay? And do you remember what the equation was? Or you can look it up if you don't know. Who's got a formula sheet? I've only got one. Eric?
N1 minus N BM 1 over SC divided by the square root of some XL minus X bar.
Okay, so what, well, yeah, S sub M1,
Oh, yeah.
what you said was also correct, but that's the simpler form of it. Now the problem is we need to find S sub M1, or S sub M, whatever, I'm just gonna call it S sub M. So what's S sub M? What's the equation for that?
S of n square root of the sum of y I minus y hat squared over n minus 2.
yi minus y hat squared
Yeah.
over n minus 2. Okay, now, isn't there another name for that? I might get this mixed up.
Standard error of the
Oh, no, you're jumping ahead.
yeah. Sorry.
That's a different equation. So so that's actually, that's the residuals. In fact, I would have written that as the residuals. So that's S sub E, okay? S sub M, or in your formula sheet, S sub B1 equals S sub E divided by the square root of xi minus x bar squared. Okay, so that's kind of where we left off yesterday. So in order to do this, we got to do all this other stuff. And so we need to, so basically this here, this is, in fact, I wouldn't write it that way. I would call this the square root of the residuals divided by n minus 2. Because y'all remember how to do a residual, right? Okay, I think we went over it in my other class, and that was the video I posted, because I got a little bit done quicker. We got a little farther than you guys. So let's talk about how do you find the residuals. Oh, it's going to have to move. Okay, how would you find the residuals?
You plug in, you use the y equals mx plus b equation on the.
Okay, so which I just moved out of the way. So I need to find the y equals mx plus b equation. So in this case, y equals 1.3991x plus 151.35. So try to put 3.5. Okay, so we're using that. How?
So then you plug in your x value, which should be the ages.
Okay, so my x value in this first one will be 25
and
times
1.399
1.3991 plus 151.35. So this is really the predicted. Well, let's put it over here. I don't know. Okay, so this is the predicted value. So essentially what we're saying is a 25-year-old person we would predict would have a cholesterol level based on this regression of 186. Okay? So we're going to do that for all of the data points here. Okay? I'm going to move that out of the way. Okay? Now, what's the residual?
and you subtract your predicted minus observed.
Predicted minus the observed. Now, does it matter whether with the order I do those in? No, because we're going to square it in a minute. Okay? So we just do that. So the first one was off by 6, second one was off by 8, third one was off by 4.5, 16, so they're all over the place. Okay? And then we're going to do the residuals squared. So that's going to be this raised to the second power. Now, by the way, do we understand what a residual actually is? Who can explain to me? How about, it's Austin, right? I don't know why I have such a hard time. I have an Austin that sits there and an Austin that sits there in my other class, and for some reason location matters to me when I remember your names. So what is the residual based on this scatter plot?
It's the space between the point
Yes, exactly right. It's the vertical distance between any point and the line. Okay? So we can see this one here when we were about 30 years old. One person was right on the money, 2 people were off. Okay? All right. Okay, so that's what the residual is. Okay, so now we're going to square it for everything, and then we're going to find the sum of the residuals squared, and that value is 4553.9. Okay? All right, so now what do I do with that number? Sean?
So I'm just going to ask with residuals. Since we're going to be making a plot with residuals, wouldn't it matter to do observed minus predicted instead of the other way around? Like, wouldn't that change the graph?
Oh, I see. That's a good question. That is a good question. Because the question, for those of you who couldn't hear on the video, he says, doesn't it really matter if we're doing a residual plot? Now, that's not part of this question, but won't that change the graph? And the answer is, yes, it will, but not really. Okay? And since you asked about the residual plot, let's do it the way that I did it here. So what did I do? I can't even remember. I did J2. So I did the predicted minus, so this is so I'm gonna rename this. This is predicted minus the observed. And then we'll do the observed minus the predicted, just to compare, just for fun. Okay, so if I do the observed minus the predicted, all of my signs will be backwards. Okay? And so since we talked about residual plots, and that's a good thing, because that'll definitely be on the final, so we'll digress for just a moment here. How do you draw a residual plot? Because you all screwed it up on the last test.
You use the residual values plus the x values.
Yeah, the x values. So don't forget the x values here. And then let's look at, this is the observed minus predicted, okay? So if I insert this, and I do a scatter plot, okay? That's observed minus predicted. Oh, this is kind of nice because it's going to have some titles here. I don't know where to put this. Right there, I guess. Okay, now we'll do the other one. We're going to grab the age, and now we're going to do the predicted minus the observed.
That's the wrong one.
Residual, very good. Age and residual. Okay, so this is the opposite order. Insert, scatter. Let's compare them side by side. What do you think?
Just flipped upside down.
Yeah, everything's flipped upside down. So, and the idea here is, so the question is, are either of these graphs a null plot? Sean's giving me the thumbs up. So that means, so who says it's a null plot? 1, 2, 3, 4, 5, 6, 7, 8, 9. Who says it's not a null plot? Nobody? Okay, so 9 of you were willing to stick your neck out. The rest of you no. Okay, so yeah, I'd probably say that's a null plot. So is that a good thing or a bad thing?
It means there's no error.
It means you have constant error variance. Okay, so that's a good thing. Now, just for fun, let me think about this.
Yeah.
Okay, let me draw a picture here, for example. So let me just say, for example, because I remember, and it might have been on the last test, I don't remember, but I remember doing a problem in which we had a plot that looked like, it seems like it looked something like this. Okay? Now, if you do your, let's pretend this is the observed minus the predicted. And let's do this one as the predicted minus the observed. What would you expect, if this is the original graph, what would you expect this graph to look like?
A U.
It would be a U. Okay. So now, when I say that, yeah, so the graphs are different, correct? But they're just oriented differently. If you got a residual plot that looked like this or this, would it matter to you?
No.
No, because what would you say? Does this have constant error variance? It does? No, it doesn't. Okay. So would regression be a good idea or a bad idea if your residual plot looks like this? It would be a bad idea. It would tell you that linear regression was not a good idea. It would tell you the same thing if it looked like this. And so that's why I say it doesn't matter. Okay? You're seeing a pattern here. We definitely see kind of a U shape here. It's not constant error variance. It's not a pattern. More likely, you would see something more like megaphones are bad. But even then, well, whatever, it might look like that. But it doesn't really matter. That's why I say it doesn't matter. Okay? Because you're looking for a pattern. If you see a pattern here, that's a problem. So ideally, you want some sort of a null plot. So there's no real pattern. Does this indicate strong correlation, weak correlation, moderate correlation, or no correlation? You can kind of see that. Okay, who says strong? Says moderate. Says weak. A couple weeks. Who says no? Yeah, no correlation. You could say weak, but no is a better answer. That's why we want the null plot. We want no correlation on our null plot. No correlation indicates you have constant error variance. Okay? Does that make sense? All right, so that was a good diversion. Let's go back to our problem. But that will be something that we could put on the final, definitely. So let's move my plots out of the way. Whatever, that's good enough for now. Okay, so we're back to our problem. We just found the sum of our residuals squared. What do we do with that number? Bueller? Tyler knows. What do we do with that number?
Are we trying to find the S of E?
We need to find the S of E. So yeah, we wrote these kind of out of orders. So yeah. So we just found the residuals. So we're going to do
The
square root of my residuals that I just found, divided by n minus 2. What's my n? N is 14, because that first line doesn't really count, right? So 14 minus 2 is 12. Okay. So I now know that my S of E is 5.62355. Okay. All right, now I need to find my S of M, which is basically my S of E. Okay, now, actually, before I do that, so this is the numerator. Maybe I'll just do that. That's my numerator. Now I need to find my denominator. What's my denominator? Okay, what do you think X bar is? Mean of the first column. Okay, so if I do the mean here, equals the mean. I wanted to type mean. Bill Gates is mean and makes me use a different command. Okay, so the mean age in here is 42 years old. Okay, so what do I do? So you could kind of think of this as the residuals for the X. Okay, so, oh, in fact, I wrote that wrong. There's supposed to be a sum in here. Sum of that. Okay, so now let's think of this as the residuals for the X. Okay, so we're going to take 25, we're going to subtract 42, and I want to subtract 42 every time, so I'm going to F for it. Okay, yes. Here, let me finish this just a second. I'm going to add this up, or I'm going to copy this down. Oh, I should have squared that. Should I square that all in one step? Sure, let's square it up. Okay, so if I square that, and then I add it up, I get that. Okay, so Tanner asked me, how did I get the 5.62? You're supposed to ask me that when we're doing it, not like 5 steps later.
So I did everything right, I just didn't put the divide by 12 in. I put divide by 12 just in the square root.
Oh, within the square root? No, don't do that.
That's what we kind of done.
Well, look at your formula sheet. What does your formula sheet say? Oh, it is under the n minus 2. You're right. Oh, I was wrong. Okay, so we did do that wrong. So Tanner was right. Let's do this. That should be within the square root there. So now that 5.62 becomes 19.48. So thank you, Tanner. Saved me from a mistake there. Okay? You should get 19.48. Does that make sense? Yeah. So read your formulas closer than I did. Okay? All right. So now I've got 2472, and I want the square root of that number here. Okay? And now, when I divide those two numbers, I'm going to get 0.3917. So that is the standard deviation of the slope. Samantha.
So you don't do the square root on the residual x's until after you add them all up?
That's correct.
Oh. This formula is very misleading.
Well, I'm just following the formula here on the formula sheet. But yeah, that's what it says. So just follow it. You've got the sum of xi minus x bar squared, and then you square root it.
So is the square root over the sum then?
Yes.
So formula you did yesterday.
Okay, look at the formula sheet. If I wrote anything on the board, this is the formula sheet's what you're going to get on the test. Okay, so the formula sheet rules. If I wrote anything wrong on the board, it's the formula sheet. Okay, this is the rule, not whatever I said wrong. Okay, formula sheet is you can trust this. Okay. All right. So I've got the standard deviation for the slope. Now I can finally find my t-score. Okay. So my t-score equals what, Chuck? What's M1 in this case? Don't know? What is it, David?
Would it be the
1.3991. It's part of your equation there. 1.3991. And what am I going to divide that by, Charles? The number I just found. What number did I just find? Yeah, SM1, which is what? What's the value? That better? Yeah, the 0.39174. That's the number I just found. Okay, so that's my t-score. So I get 3.57. Okay? All right, now I need to find my p-value. I did. I just took the, well, actually, what's the m? I ignored the m. Why did I ignore the m? Because it's 0. What does the capital M stand for? The mean?
Predicted slope.
The slope. Yeah, capital M stands for the slope, the population slope. We got 1.3991, but we don't trust that that's correct, right? We think it's correct, but we don't know. Okay? All right, so I got 3.57. Next step is to find what? The p-value. Okay, in order to find the p-value, I need to find my degrees of freedom. Okay, now, by the way, this is different from what you've been using, but here's a big hint right there. What do you think your p-value, your degrees of freedom are? N minus 2. Okay, so this one's n minus 2, not n minus 1. Okay. So your degrees of freedom, so we have 14 data points. Your degrees of freedom are 12. Okay. So my p-value is going to be equals t dot dist two-tailed. Very good. We're doing a two-tailed test. And the nice thing is that's positive, so I don't have to worry about it, right? It likes only positive values there, but if it's negative, just make it positive. Comma, 12 degrees of freedom. Okay, so that's the one tricky part here. Your degrees of freedom is n minus 2, not n minus 1. Okay, so that tells me I got a p-value of 0.003. And so Alex, what does that mean? Reject the null. And your conclusion is what'd you say? Conclusion is the m does not equal 0. That's a okay conclusion, yeah. That the slope is significantly significant. Oh, that's good enough. Significantly different than 0 if you want to be. Your slope is significant, so we can trust that. Okay, question, Tyler.
Sorry to go back a step. Finding the test statistic. So it's t equals the slope minus, which says the beta 1. What is the beta?
Remember, yeah, they use slightly different terminology, but what's beta naught and beta 1? Okay, remember, so yeah, so the formula sheet is slightly different. So if I look here, okay, so what are they assuming the null hypothesis is? Beta 1 equals 0. The alternative, beta 1, does not equal 0. I don't like that because that looks like a type 2 error, but it's not. Okay, completely different. Use the same letter for two different things. Okay, and so their formula is t equals b1 minus beta 1 over s sub b1, right? So it's the same thing. I'm just using m instead of b, beta. Everything I'm doing. Okay? Yeah, it's a good question because I just that's what you'll see on your formula sheet. So you need to be familiar with that. Yes.
You show us how to get the residual.
The residual x. Okay. So first of all, you need to find the mean. The mean is 42 years old, right? Did you do that? You missed that step. Okay. Then, you know what to do next? Okay, so all we're doing is we're doing parenthesis, this one minus that one. I'm going to add for it, and I'm going to square it. Okay? And then copy that. Okay? All right, so now we've got a conclusion. What do you think would be the next question on the test? Find the confidence interval. Okay, confidence interval is right here on your sheet. I can write it on the board if you want, or I'll just write it here. It's t sub alpha over 2 plus or minus, no, sorry, well, we do have that in there. Sorry, they have it written as b1 plus or minus t sub alpha over 2 times the square, let's see, times s sub e divided by the sum, I'm going to call this of the x residuals.
You gotta take the square root of that. Put the square root of
Squared, yes, I need a square root in there too. Okay, does that make sense? Okay, so if we do a lower and we do an upper, an ipper, we just need to figure out what my t sub alpha over 2 is. T sub alpha over 2 is going to be, how would I find my t sub alpha over 2?
Chart.
Chart or with the computer? T dot inverse, very good. Inverse, two-tailed, what do I want in my tails?
You put your p-value.
Not your p-value. What kind of a confidence interval do I want? It's the most common. 95%. So what do I want in my tails? 5%. My degrees of freedom? 12 degrees of freedom. So that gives me a value of 2.178. Okay? So I'm going to take B1. What's B1? 1.3991. It's what I got, right? Minus T sub alpha over 2 times S sub E, which I found is right there, divided by the square root of the sum of my residuals squared, which happens to be, isn't it that column? Yes, it is. That number right there. Okay? Okay, so that's my lower. Now we'll do my upper.
You had to square that.
It was already squared.
Oh, okay.
Yeah, don't square it again. Now, another thing to think about here as you're doing this, I just need to change this minus to a plus. Okay, now, some of you on your last test didn't really pay much attention to your interval to see if it made sense. Okay? Now, my question is to you, does this look correct to you and why? I got a value of 0.54 to 2.25. Does that seem like a reasonable number to you? Or did I make a mistake?
Would it be okay because you don't have 0 in the confidence interval?
Okay, so he said, would it be okay because I don't have 0 in the confidence interval? It's not what I was going for. Well, that actually answers a different question.
Can you explain it?
He's answering a different question. It's not the question I was asking, but it is an important question. What does 0 not being in the confidence interval indicate? Sample size is big enough. Well, it's 14, right? But even with a small sample size, is my sample size significant? Let me ask it that way. Does my confidence interval show that my slope is significant?
Oh, he's probably just tells.
Yes. Yes, it does, because 0 is not in my interval. Okay, now let me ask you a question. I'm going to make up a couple of numbers. 32 to 34. Does that seem like a reasonable confidence interval to you? No, because 0 is not in there, right? So it's okay from that standpoint, but why is it not okay? Why is that clearly wrong? Because why? The M should be 1.3991, right? Is that between 32 and 34? No, it's clearly wrong. Clearly wrong, okay? So when I'm looking at this, my value, 1.3991, should fit between those two values. If I get something like 32 to 34, ain't no way that's right. Because 1.3991 is not in it. Okay? So when you're checking this, there's two things to check for. Number one, is my point estimate, in this case, what's my point estimate? Oh, that was an easy question.
0?
No, it's not 0.
Your slope.
Your slope, and what's my slope? 1.3991, right? So yeah, 1.3991 should fit between those two values. It does not fit between those values. That can't possibly be right, okay? Some of you made that mistake on the last test. You didn't even look at it, and you didn't even notice, oh yeah, there's no way that can be right. I made a mistake, okay? So look at these numbers. Your point estimate should generally be, unless it's a chi-square, it should generally be right smack dab in the middle of those two. And if it's not, you did it wrong. Guaranteed you did it wrong, okay? There's other ways you can do it wrong, but that's a guaranteed you did it wrong. Sean?
So the point estimate would be like the test statistic.
The test statistic, yeah. No, not the test statistic. That's not correct. The point estimate in this case is 1.3991. It's the value I got off of my chart here.
What about like another hypothesis?
No, the test statistic won't be. The test statistic, so what it does here, remember, so I got a value of 1.3991. What does the T equation do? What did it functionally do? Anybody know? Nobody knows? Okay, so what it does here is I've got a T distribution. What's the mean of the T distribution?
0.
Well, not, I'm going to say it's 1.3991, right? I don't know. When I convert it to a T-score, I change that to a 0. And then I got a value of 3.57 standard deviations away. Not standard deviations, but roughly the same. I mean, that's basically what it is. So this area here is the area I'm finding. Because I don't know how to find the p-value directly from 1.3991. I have to convert it to a standard t, which I do with the t equation. So that the new mean becomes 0. And then I'm 3.57 standard deviations away. According to this, my p-value was, I don't remember, 0.003. So this value here, the area of that's 0.003. So does it seem likely? Is that a significant p-value? Yes, it is. It's very significant. Remember, we rejected the null. So that's significant. Significantly different than 0. Okay, I'm in the tail. I was going to cover 14.2. I didn't think we'd take the whole time on this today.
With other tests, what would be the numbers that we're comparing to the confidence interval? I guess that's where I get confused with like my p-value.
Well, it depends. Yeah, so it's a good question. It depends on the question I'm asking. Okay, so yeah, it totally depends on context. So here's the deal. If I'm asking you is, based on the confidence interval, okay, and let me pull up the confidence interval we got here because I don't remember what it was. So the correct confidence interval here, because Tyler answered a different question than the one I asked. So I've got the confidence interval of 0.54 to 2.25. Okay, now let's talk about what is our normal. When I first taught you about confidence intervals, what would you say? What would be the conclusion of this?
95% confident.
We're 95% confident that 95% confident that what? The mean is not the mean. We're not talking about the mean. The slope is between those two values, right? Now, another question to ask is, does my confidence interval indicate my slope is significant? So that's either a yes or no question, but then how do you know? So is my slope significant?
Yes.
Okay, raise your hands who says yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Who says no? Okay, yeses are correct. Why?
Because 0 is not.
Because you're going to get more points for the Y than you are going to get for the yes. Why? Because
0 is not included.
0 is not included. 0 not in the interval. Okay, you're going along here. You make a mistake here. You know that your slope is 1.3991. You get a value of negative 0.25 and negative 3.4. No, let's make that a positive 2.5. Okay? Is that correct? Now, why is that obviously clearly wrong? Because 1.3991 is not in that interval. I made a mistake. Okay, so you want to be checking two things. Is 0 in the interval, and is my point estimate in the interval? If this is not in here, you made a mistake. if this is in here, then it is significant or it's not significant? If this is in here, it's not significant. Okay? Wow, that was a long lecture. I thought we'd cover 14.2. So we'll save 14.2 for Monday. Yes?
For it not to be significant, both the slope and the zero have to be. So basically, we need to find that slope in the interval that has that slope. Right?
Say it again.
So when you were doing that, how we got the two intervals, where the slope is in between the intervals, and you said it was significant. Now,
So
that
this is
yeah.
significant because
Right, but so basically what I'm asking is for it to be not significant, both that slope and the zero would have to be in between the intervals. Like that would have to be like a negative.
for it to be not
0.2.
significant, both the point estimate and the zero would have to be in there. That's
Both,
correct.
right? Because if the point estimate's not in there, then
If
it's
the point estimate's
wrong.
not in here, it's wrong,
Okay, that's what I was,
clearly wrong.
right.
And then it's hard to make any basis on a wrong
Right.
statement.
So if it's just the zero, it's still probably wrong, because the point interval's not.
I wouldn't say that. You could be right.
All right.
All right, fun stuff, huh?
Yeah.